All right. Well, thanks for everyone for joining. I have the creators of the ICE-V Wireless on the call. We have Michael Welling and Eric Brombeau. Nice to meet you guys. Good to see you. I know Michael from the Reno office. Eric, where are you calling from?
I'm in Mesa, Arizona.
Mesa, Arizona. Awesome.
Yep.
Great. And yeah, we'll go right into it for introductions. I did a little bit of LinkedIn stalking on the both of you. So first, I'll start with Eric. From like just the basic definition of your LinkedIn profile, I got broad experience in board, FPGA, ASIC, and system implementation. You last worked as at Intel as a wireless design engineer and has been self-employed actually for like the past almost 16 years, if I'm correct.
Yeah, 2000. I left Intel in 2004 and started working for a bunch of little startups. Just doing consulting, and that's what I've been doing ever since I started out working on RF amplifier optimization stuff. Lots of FPGAs and really intense DSP system design, and then that transitioned into another job here with a local outfit in the Phoenix area, and I've been doing a lot of government contract work for various search and rescue radios and air traffic control stuff and things like that. And so that was a lot of FPGA stuff. And then along the way, I got interested in the open source FPGA work that folks like Claire Wolf had been doing, and I got involved in some of the things that Matt Venn was doing, and that sort of led into a lot of little projects with Lattice FPGAs, and this came out of that. So.
Got it. And I just want to like double check. There's like you're doing your own contracting work, self-employed. You don't have like a company name or agency. You're just Eric Brombeau.
No.
Like,
yeah, it was just me as a single person doing work for other people on an individual basis.
Got it. Okay. Well, we'll find you that way. Sounds good. And yeah, I was trying to like find your internet footprint everywhere. I know you're on Twitter. We'll talk about how you how the backers can reach you guys on Twitter. A little bit on LinkedIn, but you have that shell as as your profile pic. So we just met, so I'm really happy that you're not a shell, and I put googly eyes on it. It's just so.
Yeah, I was trying to find something interesting for an avatar that I would use everywhere, and so just had a little shell there that I took a picture of. So.
The golden ratio is always a perfect choice, so I get that.
Yeah, there you go.
And on the call, my other side here is Michael Welling. I know Michael personally from when we had our breadware days, but I'll get into that in 1 second. Michael is the founder, and you're basically if not like the person to go for QWERTY embedded design. You had this since 2016. This was kind of like a side gig when I knew you in breadware, but it's become more of a full-blown, you're doing your own thing. You're obviously working with Eric and doing all those projects. Am I right?
Yeah. I've been an independent contractor under the guise of QWERTY embedded design for quite some time now. Mm-hmm. Started out as a sole proprietor, and now it's a LLC. It helped get larger contracts that I went through, and brought me to a different level in my contract work. But yeah, it's pretty much, I've been doing the same thing as a contractor as I did for years before that. I primarily work on Linux board support and printed circuit board design using Linux SoCs, microcontrollers. I do some RTOS stuff and, of course, FPGA stuff. My experience is pretty broad, and I keep it that way to make myself more, available for projects. I do a lot of open hardware stuff, and I started doing that when I started QWERTY because I wanted to show off my skills in a kind of productive way. started making like robotics controllers, just random FPGA stuff. Went on to actually crowdfund a few projects. This will be probably the fourth or fifth one that I've done. I like to collaborate with other people. I have a Discord channel where I do that, and it's kind of where we designed the ICE-V. Originally, it kind of spawned out of some conversation on the Discord channel, and it kind of grew from there. After I saw Eric's board, I was like, we need to make this thing, and we did a board spin to switch to the certified module or the mini ESP32C3. But yeah, it's just kind of organically grown. Open hardware projects are kind of my thing in my spare time. So this is just another one of them.
Rad. But I was actually just about to ask you, and I think, Michael, you probably clarified this already, as far as like how you guys met. Again, you're calling in from Arizona, Eric, and you just mentioned that you guys just met on Discord, or that was that.
It goes back a lot farther than that.
Okay, all right.
Yeah, it was probably 10, 12 years ago or so. There was an IRC channel that was devoted to people who were doing embedded Linux stuff. And I got involved over there because of the Beagle board. There was a lot of people who were doing things on Beagle board that were on that one particular channel, and Michael was there, and a bunch of other people who were. That IRC channel has changed over the years, and it's people have gone a lot of different ways, but Michael and I have stayed in touch since then.
Gotcha.
Yeah, he's been working on open hardware since before it was cool. Kind of like he's got his own projects that are posted. And I always like that he posted and shared his designs on his own webpage, and it's always fairly clean, straightforward. Yeah, and the Beagle board kind of pulled me into the open hardware community a little bit. I met Drew Faustini ages ago, and he works for Osh Park, and he's also on the board for Beagle board. I got to know the Beagle people. I helped design the Pocket Beagle, and pretty much how I got into that group. All the embedded Linux vets kind of came out of the woodworks, invited me to their IRC channel, and I got to know a lot of them through the conferences and IRC channel. I haven't met Eric in person yet, but I've met a lot of the other guys at ELC, Scale, other like open hardware conferences.
So just since you guys all introduced yourselves, let's talk about the ICE-V Wireless. And I'm pulling this like strictly from the campaign. So of course we're going to go into more detail, but the ICE-V Wireless is an ICE40UP5K created by Lattice Semiconductor and an SP32C3 development board, which allows Wi-Fi and Bluetooth control. That's just the very basic bones of what this product or what this device is all about. My question is why was the ICE-V Wireless chosen compared to others that might be on the market or may not be on the market?
So, like I said, I've been using these Lattice ICE-40 parts for probably going on 6 or 7 years now. And the main reason that I'm attracted to them is that they're well supported by the open source FPGA toolchain. And that's, the full suite of synthesis, place and route that was initially put together by Claire Wolf, which is, now they're the Yosis HQ group that does amazing work in reverse engineering FPGAs and creating open source tools to support them. And so I had originally started out using that before the open source tools were even available. And I had built a few small projects that integrated one of those ICE-40 FPGAs along with STM32 microcontrollers. And I did a few small things with software-defined radio and audio synthesis. And of course, these days with the huge silicon shortage that's going around, the STM32 parts that I've was so comfortable with over the years are almost impossible to get now. But the folks from Espressif have a pretty nice family of parts that is still super available and really inexpensive and has a lot of capabilities. So I started about a year ago looking at what it would take to use those instead of some of the parts that I'd become more comfortable with over the years. And it was a good exploration just to go out and try some new things and get my feet wet in an area that I hadn't worked in before. So when I started looking at Michael's Discord, he had some stuff on there with RISC-V, and I was thinking, well, the Espressif parts have a RISC-V version, and so I tried a little board based on RISC-V and had some reasonable success with that. And then I thought, well, gee, the next thing to try would be integrating that with one of these FPGAs. And then I got some feedback. We just started kicking the idea around on Discord, and I got some feedback from other people saying, hey, if it's wireless, maybe it'd be a good idea that it would run off of a battery. And so we just started, brainstorming, and the idea of having, a wireless Espressif, ESP32 part, and an FPGA and a battery, and super accessible general purpose I/O that you could just hook anything up to, all came together. And so I don't know how long, it was probably like 3 months ago or so, we finally got the first working hardware of the one that I designed, which was designed as a standalone chip. It wasn't using the pre-certified module that the current ICE-V hardware has. But we got it up and running, and then I started really putting my nose to the grindstone on what it takes to make the wireless interfacing work. Part of the problem that I've had with a lot of the ICE-40 boards that I've worked with in the past is that they connect almost exclusively over USB. If you want to program the FPGA, you got to plug it into your computer, and you got to use these kind of clunky old FTDI-based USB serial interfaces, which are kind of slow. So I was looking for a way to speed that up a little bit. And when I first started getting the Wi-Fi based networking for loading the FPGA working on the ICE-V, I was really amazed at how fast it goes. I mean, it was orders of magnitude faster than you can do over USB for some reason. And so that was, really stood out to me as kind of the important distinction that this board has from others, is that not only do you not have to have it hooked up to your computer by USB, you could have it across the room, you could have it across the other side of the building, and you could still talk to the FPGA. But when you do talk to it, it's very fast. You can load a new design into it in the blink of an eye, and immediately start working with it to see if it's doing what you want. So that's been a real help for. I've just been poking around on it here for the last month or so, and that's been a big advantage from my standpoint. We've seen, I guess, some questions about the utility of that, but I think we can dive into those questions a little bit later.
Yeah.
Good. Thank you. No, thank you for just explaining that. And then that kind of goes into the next question, I guess. In what applications do you imagine this would be best for? And like you mentioned, we do have a question that I found. Shout out to CNX Software. They did write a article about your guys, the ICE-V Wireless. Again, just at this point of pre-launch, or in the campaign's in motion right now, you guys are at least at 69 or something more percent that I checked
Yeah, I think it's
last?
59.
Okay, perfect. Then, yeah. So before we get to that question, I guess, or maybe it just ties in that question, I'll just read it out now. This was a question that popped in the forum on the CNX software. And one of the commenters was saying, it's particularly unclear to me, going by quote here, excuse me, quote, it's particularly unclear to me what battery-powered application could benefit from combining an FPGA and a wireless module. There probably are, but there isn't a tiny niche market. But isn't this a tiny niche market? So I guess I'll just leave this up to the question of, and what applications do you imagine this would be best for? And then potentially address like how that FPGA and that the combination of the battery power are working.
Yeah, I think I can address that. So, the first thing was, well, it's wireless, so battery power operation would be a good thing because you can just take it off and stick it somewhere where you wouldn't be easy to get at. And I've done some experiments. I've got a 2,000 milliamp hour battery that I've got hooked up to the prototypes here, and I've been able to run it for a day and a half, 2 days between charges. And then you combine that with, say, a solar-powered charger. You might conceivably be able to put that in a remote location and operate it continuously. But the question then is, okay, so you can do it wirelessly, you can do it remotely without having it attached to your computer. Why would you want to do that? And that's a really good question. Now, I've got a couple applications in mind that I like software-defined radio, and there's a few things. I've got a few little PMOD boards that would plug directly into this thing that would allow you to do, software-defined radio reception. So imagine one of the applications that I've got is an ADS-B receiver. So for people who like to, it's kind of a hobbyist thing. People have receivers set up that can pull in the signals that all commercial aircraft broadcast while they're in flight. And you have to have an antenna that's located at a high location, clear from other electrical equipment that would interfere with it, in order to get the best quality reception on those. Well, what if you were to take one of these things, put it right next to the antenna, put it up on the roof, and have all of the ADS-B traffic routed into your network directly from the board itself with no other servers necessary in between? That is an application that I can think of right off the top of my head. And that allows you to have the greatest possible signal to noise ratio on your receiver, and it allows you to locate it in a place where the antenna gets the best reception, and you don't have to run long wires to of expensive cabling in order to get your good signal. So that is one application that I can think of. There's a lot of other remote sensing things that I could think of. Suppose you wanted to put some sort of sensor network, say around your garden, for instance, and you wanted to locate that outside in the garden, and you have an FPGA taking, collecting data and routing it into the Wi-Fi network through the ESP32C3. Those are the sorts of things that I can imagine being used for. So.
Got that.
Yeah, I think the limitation is the imagination on this one. FPGAs are kind of like an open book. You can make whatever you want of it within the limits of the number of lookup tables, the logic space. So, I mean, we're just using it to program the FPGA now. It doesn't mean that's how it's going to end up like working for applications. You could load a profile onto the radio to present it as a Wi-Fi, socket or whatever you need to pass data to and fro. And you can do interactive displays, robotics. There's a lot of things you can do. It's just a matter of figuring it out. And all the applications will be niche. And we're not saying it's not going to be like a niche market, because we're only making 250 of these max on the first try. It's a very niche project, and that's kind of where GroupGets shines. They allow people to create small batch products and get them out to people. And if things grow from there, they grow from there. You know, if they find a market, you find a market, and you can validate that your product is actually worth something by putting it out there and saying, okay, is anybody going to buy this thing? They do. And then, you know, you will keep working on it, and refining it, bringing in new features. And this thing can be like, there's going to be so many places where people can contribute that the applications are immense. There's so many of them that it's hard to kind of list them all, you know? So yeah, I think that it's just it's going to end up being a part of a niche product or whatever, you know, or, you know, fun application. But yeah, I don't think we're trying to be some huge, you know, thing. It's more of, you know, get the boards out to people,
Right.
have fun with FPGAs.
Right. We're not trying to be the be all and end all, you know, Raspberry Pi of FPGAs here. We've got, you know, an opportunity. You know, part of the reason why this looked like a good idea was you know, despite the silicon shortage, we did find a sudden availability of the particular FPGAs, and it was like, okay, now's the time to give this a shot. You know, and then 2 weeks later, they were all gone, but we managed to get them. So.
Yeah.
But you know, and I think even so, that there's a lot of other FPGA based maker type products that are out there, and they're flourishing because they're usable for so many things. And you can't underestimate the value of just using it in an educational context. And that Michael has been looking into what it takes to integrate this with some of the you know, educational type things like iStudio and things like that. And I'm looking, you know, we're trying to recruit some other beta testers who can integrate this with other development environments like Zephyr. And I'm looking into what it takes to bring it into the Arduino integrated development environment. I've been working on that for the last few days, and all of this stuff is going to go onto our GitHub. It's going to be available for everybody to use. You know, if they want to go up there and grab some source code and basically start ripping and tearing at it and making it do whatever is best for their particular application. That's what we want to support. You know, we're not having any illusions about this thing being a 100% productized thing that somebody can pick up and it is immediately useful to them. This is definitely something that takes, you know, user assembly required. So.
Yeah,
and I'm working on Lattice support and possibly CircuitPython / MicroPython for the ESP, just kind of expand the ecosystem a little bit, bring in different, you know, code bases. So yeah, it's been there's a lot of work to do and not a lot of time to do it.
perfect. No, I get it. And again, thank you both for explaining that. I will not undercut it by saying, though, that Michael, the low 5 did go to DigiKey. So you never know if something, you know, becomes bigger than maybe than what it was originally intended. But yeah. So no, that's It's really cool that again, thank you guys for addressing that question. It was certainly just like it was part of that forum that I maybe I'll follow up, but this video might be able to answer that question for anyone else who's kind of thinking that in the back of their head as well. To your guys' point, so Michael, you were right. You guys are currently at 59% as this campaign is going on for ICE-V Wireless. There are only 250 units available. Lead time is 28 days once we have everything fully funded, ready to go. From that update you guys mentioned, and again, you guys went into a little bit more detail about incorporating iStudio, but mentions that again, quote, you guys are working on provisioning soft AP and supporting iStudio software. Is there any other notes that you had about this, or why you guys are adding this feature?
Yeah, so the soft AP stuff, the original version of the software that I made if you wanted to use it, you had to be comfortable with the Espressif's development environment. And that means, getting in and modifying the C source code and recompiling it and loading the firmware into the system. And you really couldn't use it on your own wireless network unless you were comfortable doing those operations. Our goal here is to add what's called soft access point to it, which would allow it to, the user could out of the box plug it into a USB power supply, and it will immediately put up its own little network with a web page on it that allows you to go in and tell it, here's the name of my network, here's the password for my network, connect to that, and then the system will reconfigure itself so the next time you power it up, it comes up on your network and you can talk to it from any machine that you have. So that's just sort of a nice way to make it more friendly for people who aren't completely comfortable working with the development tools that we use. They should be able to, out of the box at least, send FPGA designs to it, get things going, and then as they come up to speed and get more comfortable with all of the things that are going on here, then maybe they can customize the firmware. But if they don't want to, then they can use it the way, we provide some simple utilities that allow them to get by without doing any of that. So that's what soft AP means for us.
Got it. Okay. And then into that same update, there are a few minor hardware updates. Michael, what are those updates going to be?
Yeah, so on the first version of the board, I noticed that these push buttons here are a little close to this connector, so you kind of if you would populate that header, it's kind of harder to get. So I'm going to pull those back just to hit, like, maybe move the silk from the top to the bottom and push the buttons up so they're a little easy to access. That's maybe a little bit of a routing. There was a piece of routing that I missed that I want to clean up a little bit. There's not going to be any BOM changes. And
we might go in and make it so that it charges at a slightly higher current. But
right, yeah, we can tailor the limit current on the battery charger with a slightly different resistor, which is a subtle BOM change, and it shouldn't be a problem sourcing a resistor. But the ICE-40 and the ESP are kind of locked in place now, and the PSRAM. But yeah, it's completely like small, like incremental changes to the PCB for a little bit of ergonomics when you're using it, and then kind of just bump the rev, and it should be ready to go. I'll have to do the board panelization, bring it to the board house, make sure that they're okay with it, and then just kind of handle the logistics of getting all the parts ordered when the campaign's done. We did pre-order a number of parts. I think so far it's been the ICE-40, which if we didn't order that, we wouldn't have had these boards. They're not going to happen until next year sometime for another batch. And we also ordered one of the regulators because it was only in stock at Microchip, and I didn't want to risk, waiting around and once the campaign closes, if they're not at vendors and they're only at, Microchip, there's a risk of them running out there. So we just said, okay, let's order those in advance. And happily, GroupGets is actually taking care of funding that, which has been quite nice. I'm guessing they don't do a lot of the time, but
it's because we like you, Michael, I guess.
Yeah, I tend to help you guys out a lot, and I guess it's coming back.
Mm-hmm.
But yeah, it's nothing huge changing on the hardware. Just some very minor stuff. And we verified pretty much the whole circuit. So the rev that as it is now, it's perfectly functional. I'm looking at just minor changes to make it a little more user friendly, like on the use of the buttons, and then just OCD fixes on the traces. But nothing that's going to move parts around or do anything besides buttons.
Got it.
So, yeah.
Okay, fair enough. Well, thank you both for providing that update for us. Yeah, I want to make sure that if there's any other questions that maybe the backers have or anything, want to make sure to provide either I would say one of the best ways that you can ask a question about the ICE-V Wireless, whether it be pertaining to tech specs or even to about the shipping dates or any kind of anything related to the campaign, you can always go to the GroupGets site under their campaign, and under the Discuss tab, you can create your account or log into your account and post questions there. I'll see it, they'll see it, so I just wanted to make sure that's clear. What are the other ways that potentially, maybe they want to go on social and kind of badger you guys there? I have Michael on Twitter at QWERTY Embedded, so at QWERTY Embedded. I also have Eric Bramba at eBramba on Twitter. So those are good channels to meet. You also mentioned you guys, or Michael at least, has his discourse. Would that also be a good area or way to connect with you guys?
Yeah. If anybody wants to be involved in the project, we have a channel for the project on my Discord server. I can post a link to the Discord server in the updates on the campaign, and I guess maybe give you a link to add to the video here.
I'll add that in the description.
Yeah. I created it when I started the Pi 5 project, which is a different project that I'm working on. And then it kind of just grew into a lot of different things. All community collaboration, open hardware mostly, and maybe some mentorship here and there. A lot of different things.
Yeah, a lot of the folks who have done really excellent work in open source hardware are hanging out, are available on that Discord server. So yeah, if you want to get involved in this stuff, this is a great place to meet people and kick ideas around. So.
Yeah, and then you probably end up at the 1-Bit Squared Discord as well, which has a huge community and very helpful.
Perfect. Yeah, we'll post, or I'll link that within the description below, or if I have editing power, maybe I'll put it right where my fingers are, or here. I don't know where that will go, but I'll make sure to put those links in.
Okay.
Well, gentlemen, thank you. Yeah, that is the end of my questions. Again, I'll probably be scouring the internet again. If there are any other questions, I'll at least email or tweet it to you guys. Is there anything else you want to address with the campaign backers, or anything else that you guys want to mention before we close?
Just definitely encourage people to get onto the GroupGets site and get that discussion area active. There's nothing going on there right now, but we're checking it every day to see if anybody's got questions or comments, and we're happy to talk with people about it. And even if you didn't buy one, if you have questions pre-purchase, we'll be there to help you out on it. So.
Yeah, and the ideas like for applications or demos are great to have and to understand where people want to see things happen. I think in the educational, we'd probably want to maybe get some PMOD recommendations for people. So I'm probably going to work on a list of PMODs that might be useful for various applications. There's some that are available on DigiKey directly from Digilent, which are there's quite a variety and a lot of like analog stuff. So if you're into analog, you're in luck. There's some basic newbie like LED/dip switch type stuff, which might be useful for demos and educational type environments. And then there's, other ones that are kind of custom or more, small batch. 1BitSquared has a number of PMODs that people can use, HDMI, output, LED outputs, and I think there could be quite a few like neat like LED type projects that you could make with this.
Yeah. For people who aren't totally familiar with the FPGA world, PMODs are the standardized hardware interface that hooks up to the three big connectors on the top of the board, and you can make your own. I've made my own, like this one here. That this is designed to do VGA and television and audio and PS2 for some of the projects that I've done. And so what you end up doing is just plugging them together, and you end up with something that looks like that. And then you can, off to the races for your multimedia experience. So there's a whole lot of pre-made PMODs out there for people who want. Digilant and 1BitSquared and all kinds of people make these with, SD card interfaces, PS2 interfaces, video interfaces, analog digital interfacing, RF, that kind of stuff. So, any kind of stuff you want to do, chances are they're already out there. But if you need something special, it's easy to roll your own too.
Yeah. And we encourage it.
Fair enough. Well, thank you guys so much. Like we mentioned, the campaign as we are recording now is at 59%. That was literally just a week, so I anticipate these units will be coming out pretty fast now. So we're a little over halfway over 250 units sold, so, or at least backed. So thank you guys so much for joining the call. We'll definitely be posting more updates and stuff as time. These guys have been really good about using the updates feature, so they'll be posting more updates, and we'll also be sharing that on our social as well, on Twitter, Instagram, yada, 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 where all the kids go. Thank you guys so much. I appreciate you guys' time.
Yeah,